We are now going to learn how to use the standard normal table to find percentages under any normal distribution. And to do this, we're going to put together what we learned about the z-score together with the standard normal table, and then using those together, we're going to be able to apply the standard normal table to any normal distribution. So let me grab my standard normal table here. Okay, so remember these have z-scores, so you look up z-scores on this table. Okay, so now for this particular example, and I'm going to maybe zoom in here. So for this particular example, this says the height of adult males is normally distributed with a mean of 69 inches and a standard deviation of 7 inches. What percent of adult males are taller than 80 inches? So what you need to do is think of this as a problem where you're finding the area above a z-score. And the z-score is the z-score for 80 inches. Because you see, all normal distributions have the same percentages relative to the z-scores. So you only need the one table, but you got to go through the you got to go through the z-score in order to apply it to other normal distributions. So let me show you how this works. Okay, so I'm going to draw my curve. And the mean here is 69 with a standard deviation of 7. So it's no longer 0 there in the center. It's the mean of the distribution, which has a z-score of 0, right? The z-score down here would be 0. And 80 inches, that lies, more than one standard deviation above the mean, but not quite 2 standard deviations. So 2 standard deviations would be 83 standard, or 83 inches would be 2 standard deviations above the mean. Okay, so 80 inches, this doesn't have to be perfect, but it might be like about there. Okay, and what I want is I want this portion of the population. So this is the distribution of the whole population. So by getting this area, I'm going to get the percent of the entire population of adult males that are taller than 80 inches. Okay, so to look up and find this area, I need the z-score, okay, because this table is in terms of z-scores. So I got to find the z-score for 80. So 80 is like your x, right? So if you remember the z-score formula here was like this. Z is equal to the x that you want to convert minus the mean divided by the standard deviation. That was the z-score formula that we learned in the very first video last time. So in this example, if I'm going to convert 80 inches, I'm going to take 80 minus 69 and divide that by 7. Okay, and then I put this into my calculator, and remember, you got to be careful when you do this. Okay, I have 80 minus 69, and then I'm going to divide the difference by 7. So I got to hit equals and then divide the answer by 7, and I get 1.57. So what that means is that's actually the z-score for 80 inches, 1.57. And so the idea here is the area above the z-score 1.57 is equal to the area that's above 80 inches. So really what I'm doing is I'm looking up this area on the table, but I have to go through this z-score to do it. So you have to remember, in the last video when we learned how to do this table, there were 3 cases. Okay, one case was where you wanted the area below, and in that case you just looked it up on the table, and these areas are always going to be the area below the z-score. The other case is if I want to find the area above, which means I have to look up the z-score on the table and get the area below, but then I have to subtract from 1 to get the area above, and that's what I need to do in this case. And then there was the area between two z-scores, where you look them both up, subtract the two areas. Okay, so what I'm going to do is I'm going to look up 1.57 on the positive side of my table. So 1.5 and then 7 is right here, 1.57, and I get 0.9418. Okay, so this is 0.9418. Let me just make sure that's right. Yep. And so that of course is all the area below this z-score, which is, you know, way too much, like 94% of the area is below it. So what I want is this area above it, and so I subtract from 1. This is a lot like the complement rule when we did probabilities. In other words, the area below plus the area above adds up to 1. Okay, so 1 minus 0.9418, and I get 0.0582. And that is that final answer that I'm looking for. So it's 5.82% of adult males are taller than 80 inches. Given that the heights are normally distributed with this mean and this standard deviation. Given that, then that would be the percentage that are above 80 inches. Okay? And another way that you can think of this also, you can kind of think of it as a probability. If I randomly reached into the population and pulled out an adult male, then the probability that they would be taller than 80 inches would be 0.0582, or 5.82% of the time you're going to pull out an adult male taller than 80 inches. And the reason for that is because that is the percent of adult males that are taller than 80 inches. Okay? So, this is kind of the big finish, actually, to the whole class. This is the last thing we're going to do this semester. And so if you got this, if you see what we're doing here, how we're getting the z-score before looking it up on the table, you should be good here. So let me do another example, and then the next couple of videos I'm going to give some for you to try. Okay? So in this one it says the weight of newborns is normally distributed with a mean of 72 pounds and a standard deviation of 13 pounds, or I'm sorry, 1.3 pounds. So the mean weight is 7.2 pounds, standard deviation of 1.3 pounds. Now it asks what percent of newborns weigh between 6 and 7 pounds. So what you see here is that this is actually a between probability. This is the third case where we're going to get two different z-scores here. We're going to have to find the z-score for each one, and we're going to find the area between them. Okay, now the center here is 7.2. Okay, so the center is 7.2, standard deviation is 1.3. So the center is not 0, but the z-score is 0. Okay? And then 6 and 7, they both lie below the mean somewhere. 6 and 7 are both below the mean. One really close to the mean, one further away. And then what I want to do is I want to find this area between. This doesn't have to be perfect. It's just important that they're on the correct side of the mean and you make it somewhat realistic. Okay? And so I want the area between these two values. So what I got to do is I got to find the z-score for each one of them. So the first one, I find the z-score for 6 by taking 6 minus the mean, 7.2, divided by 1.3. Okay, so 6 minus 7.2 divided by 1.3. So am I going to get the right answer when I hit equals? I'm not, because it's going to divide first and then subtract, but what I really want it to do is subtract first and then divide. So you see you're going to get a wrong answer. The z-score is not 0.46. Okay, so what you should do, what I do is take 6 minus 7.2, hit equals, and then divide that by 1.3. And I see that my z-score is negative 0.92. So what this is here is negative 0.92. So this isn't completely realistic because that doesn't lie less than one standard deviation. They should have both been kind of closer to the mean, but this is okay. This still gets the order of things right. Okay, so now I need to find the z-score for 7. So I do 7 minus 7.2 divided by 1.3. So 7 minus 7.2 divided by 1.3. Negative 1, or negative 0.15. And so that's this one here. Z is equal to negative 0.15. And so really what I want to do is I want to find the area between these two z-scores. Okay, so I'm going to find the area for negative 1.5 first. So I'm going to be on the negative side for both of these. So 0.1, 0.05, I get 0.4404. And then for 6, I'm going to look up negative 0.92. So negative 0.92, and I get 0.1788. Okay. Let me show you a common mistake that gets made. Sometimes if you try to count, like you think, boy, 2, I want to look up negative 0.92, and so you look over 2. That's actually 0.01, and the reason is because it starts with 0.00. So you don't want to look over 2, you have to look over to this third one. So you really want to use these on top, okay, to make sure you get the right area. Okay, so now the area of the percentage between these two I'm going to get by subtracting these two. So this is just the third case where you find a between probability. You have to look them both up and then subtract the two areas. So you can't forget those 3 cases from earlier videos. Everything here is built on those. Okay, and I get 0.2616. And that's the area, so the percentage would be 26.16% of the population of newborns is between 6 and 7 pounds. Okay? So that is what we're doing. So the idea is very similar. It's going to be one of the 3 cases here. It'll be one of the 3 cases, but you're going to be dealing with the actual values of the population, the actual observations, or the X values. And so you got to convert them into z-scores before you look it up on the table. Otherwise, it's very similar to what we did before. It just has the extra step of going through the z-score in order to get the area from the table. So in the next couple videos, I'll just give you some of these to try, and you see if you can do these correctly. And then I think you should be ready for the homework.